Welcome back to the deep dive. Today we're tackling something pretty dense, but really important. It's an internal corporate environment, health, and safety document. The official title is the Chemical Management Standard, EHMPG 13, Revision 00.
Sounds a bit dry, maybe.
A little. But this is basically the rule book for major construction and engineering sites, specifically the ones run by the Electromechanical Project Group, or EMPG.
That's right. Big projects, lots of potential hazards.
So our goal here is to kind of cut through the jargon. We want to understand, how do these big sites actually manage dangerous chemicals day to day? Who's ultimately responsible? And apparently there are some, let's say, very clear zero tolerance rules in here, things you just don't do.
Yeah, and it's really critical to understand this isn't just some optional internal policy, not a nice to have. This document is the actual framework. It's built to prevent serious accidents, minimize damage to the environment, and crucially, make sure they're complying with a whole stack of legal requirements at the same time.
Okay, so it's tying everything together.
Absolutely. You just look at the references they cite. It's everything from specific local laws, like the Factories Act from way back in 1948, and the Hazardous Chemicals Rules from 2016, all the way up to international standards like ISO 45001.
Wow, okay. So it spans quite a range.
It does. And the core purpose, really, it's spelled out. Establish the minimum requirements for managing safety, health, environmental risks. And that covers everything. Storing chemicals, using them, disposing of them, even reusing them.
All right, so let's unpack the tools the system uses. To manage all that risk, you need good information, right? The standard talks about two key documents. These seem to be the backbone of their safety communication. What are they?
Yeah, and we really need to distinguish between these two. They serve different purposes. First, you've got the Material Safety Data Sheet, the MSDS. Now, this is the official legal document. It comes straight from the manufacturer. It lays out all the hazards, the precautions you need to take. And the key thing is, it must be kept right there on site at the point where the chemical is actually being used.
Okay, so that's the comprehensive source, the legal truth from the maker. But then, why does the standard insist on this second document? The Safe Use Instruction, or SUI, isn't the MSDS enough?
That's a great question, and it points right to the practical challenge. An MSDS can be, 10, 15, 16 pages long,
Yeah.
and it's often written in a very technical language, not exactly user-friendly if you're on the shop floor.
Right. Not something you can quickly glance at.
Exactly. So this is where the SUI comes in, and it's actually really interesting. It's the localized, practical guide. These standard mandates, it must be a one-pager, developed by the site's EHS team.
Ah, okay, one page.
One page. It basically strips away all the legal complexity from the MSDS. It takes the core hazard info and gives employees specific, actionable, often visual instructions for their immediate work area. It translates that dense MSDS into, okay, here's what you need to do right here, right now with this chemical.
So the site EHS rep is essentially the translator, taking the legal doc and making it a practical checklist for the worker. That translation step sounds absolutely critical, maybe the most crucial part.
It really is the linchpin. Makes the whole system usable. And just to be clear, when they say chemicals, they mean pretty much everything: solids, liquids, gases, mixtures. Broad definition. And the standard pays special attention to what it calls secondary containers, like if you pour some solvent into a smaller can for use.
Okay.
And also transfer containers for moving stuff between locations. Each type has specific rules, especially around labeling.
Got it. Okay, so if you have this complex system, accountability is everything. If something goes wrong, you need to know exactly who dropped the ball. So let's walk through that hierarchy. Who does what?
Yeah, the standard is super clear on this. Responsibility is layered. Right at the base level, you have the workmen. Their job is actually pretty straightforward, but essential. Two things. Attend the training they have to be trained on the MSDS and that SUI we talked about. And second, just follow those instructions. Handle and steer the chemicals exactly as the SUI and MSDS say. Their role is basically compliance.
Simple enough, follow the rules. So moving up a level, the site management folks, supervisors, engineers, what's their specific prevention role?
Okay, so site management supervisors, engineers, construction managers, they're the operational owners on the ground. Their main job is doing the initial hazard identification and risk assessments, the HIRA.
HIRA.
Yeah, HIRA. They have to do this for all the chemical activities.
Yeah.
Loading it, storing it, moving it, using it. And this is key because it forces the team actually doing the work to think about the risks before they start. Own the risks.
Right. Proactive, not reactive.
Exactly. Then they have to implement the control measures that come out of that HIRA. And importantly, they have to make sure the MSDS and the SUI are actually displayed right there in the chemical storage areas. Visible.
That's quite a bit of responsibility doing a HIRA for every single chemical process. So who pulls all this together? Who coordinates it all?
That falls to the project EHS representative. They're kind of the central hub for chemical safety on the project. They have to maintain and update the master list of chemicals being used on site, and they communicate that list out every single month.
A master list, updated monthly.
Yep. And crucially, they're the ones who actually develop those one-page SUI documents we discussed. They also have to validate that the training is actually happening and that it's effective. Check the box isn't enough. And of course, they're responsible for making sure any incidents, near misses, or HIPOs, that's high potential incidents, get reported properly up the chain.
So the EHS rep is the tactical engine room. What about the topsite leadership, the project manager, the project director, or PD? What's their high-level role?
Their role is less about the day-to-day creation of documents and more about strategic oversight and verification. The project manager, or PD, is ultimately responsible for making sure this entire standard is implemented effectively across their project. Full stop. And this is important. They have to get out there themselves. They are required to conduct safety observation tours, or SOTs, safety observation tours, and specifically target areas where chemical hazards exist. They need to see it for themselves.
Interesting. Why specify the project manager has to do the SOTs? Why not just have them review reports?
Because it's about visible leadership. The standard demands that senior management is directly involved. When the project manager walks the site, looks at chemical storage, asks questions, reviews the corrective actions right there, it sends a powerful message down the line. This EHS stuff isn't just paperwork, it's a core priority right from the top.
Visible commitment.
Exactly. And above them, you've got the delivery head. They review the progress of how this standard is being implemented every single month in formal EHS review meetings. So there's higher level oversight too.
Okay, that makes sense.
And this whole structure is enforced by some pretty strict procedures. For instance, a user, say a subcontractor, must submit the MSDS for a new chemical to the EHS team before they can even bring it onto the site.
Ah, a pre-approval gate.
Absolutely, non-negotiable. Because that submission triggers the whole process. The EHS team needs that MSDS to do the risk assessment, the HIRA, and then create that vital one-page SUI. No MSDS, no SUI, no use.
Right. Let's shift gears slightly to the really practical, maybe even harsh rules. The zero-tolerance stuff aimed at managing physical risk right there on the site. These seem like the rules designed to stop simple mistakes becoming disasters. What are the absolute must-dos or must-don'ts?
Okay, number one, absolutely critical. Labeling. Every single one of those secondary and transfer containers, the little cans, the jugs you use on the job, must be labeled correctly. Minimum information. Chemical name, the main hazard, and the hazard symbol. Usually following a standard format, like GHS, which they detail in an annexure. No excuses.
Standard practice, you'd hope, but making it mandatory is key. Okay, what else? What's the really explicit rule that maybe gets at, human behavior?
This one is fascinating because it's so basic, yet clearly necessary. It really makes you think about the assumptions you have to make when designing safety procedures. The most explicit zero-tolerance rule aimed squarely at preventing accidental ingestion is, do not store chemicals in any type of drinking water bottle.
Wow.
Or any container that was previously used for food or drink, period.
Wow. That single rule tells you so much about the environment they're planning for, doesn't it? You're anticipating that unless you spell it out in giant letters, someone might just grab an old plastic water bottle to store some solvent because it's convenient.
Precisely. It bypasses complex risk assessment and just says, don't do this incredibly dangerous, easily mistaken thing. It's about managing predictable, if unsafe, human shortcuts.
And it's simple, easy to check, easy to enforce.
Dead simple.
And
effective. Beyond that, physical storage rules are also very strict. Chemicals always have to be stored away from combustible materials. Makes sense? And anything flammable needs its own dedicated, certified flame-proof storage cabinet. Not just any old locker.
Okay, proper hardware.
Proper hardware. And then there's chemical compatibility. You can't just stick any two chemicals next to each other. The standard requires using a chemical compatibility matrix, which is usually in an appendix. It clearly shows which chemicals react badly together. Like if chemical A and chemical C are marked not compatible,
right,
they absolutely must be stored separately. Physical separation, defined distances, maybe even barriers to prevent nasty reactions if something spills or leaks.
Okay, so segregation is key. We've touched on training a few times. Given how complex this is, and maybe staff turnover on big projects, how often do people need this training refreshed?
Yeah, the standard is quite prescriptive about frequency, likely to combat that knowledge fade or people moving roles.
Hmm.
For employees who are actually handling or storing the chemicals day to day, they need retraining on the specifics, the MSDS details, and that one-page SUI at least once every 6 months.
Every 6 months. Okay, pretty frequent.
It is. And for the supervisors and engineers, the ones managing the system, doing the HIRAs, they need training on the entire chemical management standard, the whole document we're discussing, once every year, annually.
Right. Different levels, different frequencies. Makes sense. So let's look at the final piece then, the management systems. How do the senior leaders actually know if this whole program is working? I mean, beyond just counting accidents, how do they make sure it's not just, shelfware, that it's actually effective in the field?
They do that through very specific key performance measuring indicators, or KPIs. And these aren't just tracked. They are formally reviewed every single month by the top leadership regional delivery heads, the project directors, the EHS leaders. And the focus of these KPIs is interesting. They're designed to catch gaps in the process, system failures, not just wait for an incident.
Okay, so tracking the absence of failure, in a way. What are they actually measuring each month? What are those specific metrics they're watching?
Well, they focus heavily on documentation control and compliance gaps, which tells you where the system might be weak. For example, they track the number of chemicals found being used without proper documentation.
Meaning no MSDS or no HIRA done or no FUI prepared?
Exactly. If a chemical is in use and those pieces are missing, that's a major red flag, a failure of that pre-approval control we talked about.
Okay, what else?
They also track the number of chemicals that don't meet the labeling requirements. Straightforward compliance check on that basic rule.
Right, the labeling we discussed.
Yep. Then, the number of employees trained versus the number who require training. Are they keeping up? And finally, they look at waste collection and disposal. Is it complying with all the legal requirements? That's often treated as a simple yes-no compliance check each month.
That's really revealing. The fact that the main KPIs are about missing paperwork and bad labels, not just injury rates. It suggests they know the most common failures start with those basic administrative controls breaking down.
I think that's exactly right. It shows leadership get stories, that the process controls, the boring stuff sometimes, are actually the best preventative measures. Stop the problem before it starts. And it doesn't stop with monthly KPIs. The standard also mandates an annual self-assessment.
An internal audit.
Pretty much. Conducted by the internal champion for this standard and the EHS leaders. They have to formally evaluate how effective the whole chemical management standard has been over the year. That forces them to think about continuous improvement, not just maintaining the status quo.
And how long do they keep all this data, the records?
Well, the critical operational records, like that master list of chemicals, all the SUIs they've developed, the compatibility matrix, those are classified as ongoing records. They need to be kept current. And the standard itself, the whole document, has a built-in expiry. It must be formally reviewed and revised at least every 3 years from its last revision date.
Keeps it relevant.
Exactly.
Yeah.
Ensures it keeps up with changing regulations, new chemicals, industry best practices.
Okay, so let's try and synthesize this. What does this deep dive into one company's chemical standard mean for you, our listener? Whether you're handling chemicals or just managing any kind of complex, high-risk information, what we've really seen is that managing this stuff effectively isn't just about having rules. It's about building this exhaustive system that translates the really complex stuff, like a legal MSDS, into something incredibly simple and actionable, like that one-page SUI. It's about tying every single person, from the worker on the floor to the project director, to specific tasks and responsibilities, and then crucially, measuring success not just by the absence of disaster, but by the health of those basic administrative controls, the documentation, the labeling, the training.
Yeah, and if you connect this to the bigger picture, this level of, almost obsessive detail, it really highlights how true operational safety needs more than just good intentions or abstract compliance. You need a formalized, documented system of checks and balances, a complete loop. It runs all the way from that simple rule the worker follows, don't use a water bottle, right up to the high-level KPI review by the delivery head, checking if chemicals are being used without the right paperwork. It ensures every single hazardous material is accounted for, tracked, and controlled through its entire life cycle on that site.
It's a closed-loop system, ideally.
That's the goal.
So here's a final thought to leave you with, something maybe to mull over. Think about that one incredibly simple, explicit rule. Do not store chemicals in drinking water bottles. Given how necessary that rule clearly is, what does its existence tell us about the fundamental, very human assumptions we absolutely must challenge when we design any safety procedure for any complex environment? Complexity might be managed by sophisticated systems, sure, but maybe, just maybe, the most critical accidents are prevented by achieving crystal clear, simple, unambiguous rules right at the sharp end, at the point of use. So maybe ask yourself, what kind of one-pager SUI do you need to create? What's the complex thing in your world that needs radical simplification to be truly safe and effective? Thanks for diving deep with us today.